Hello, welcome. Being that this is a virtual conversation, I can take off my mask and we can speak somewhat freely. This is a conversation and welcome to What's New at ATS Life Science. I'm Stan Kleine-Kink. I am the Director of New Innovations and Technology at the ATS Innovation Center. I have extensive experience working on many automation systems, right from the requirements and concept design through validation, production, retrofitting, and even decommissioning. ATS, we're very excited about all the manufacturing innovations and the role that we play in these innovations. That said, our focus is also on what's moving forward and the changes that are coming. I'm here to discuss what's new in ATS Life Science. Our commitment to innovation is recently exemplified in opening of dedicated innovation centers in Cambridge and Kingston, Ontario. Along with our dedicated staff, these facilities allow us to accelerate our learning and technology as we partner with customers, suppliers, and educational institutions in these spaces. This gives us the opportunity of not only working independently, but working with many people to go and drive change. It's a place where we not only develop new assembly and platform technologies, but we also support customers in developing repeatable and robust processes. These spaces allow us to transform ideas. And ATS, we have ideas. ATS ideas revolve around both continuously improving and transforming manufacturing. For a long time, we've done a fair bit of continuous and disruptive improvements on projects, but we realize we cannot drive exclusively through our projects-based work. We need true innovation and innovative solutions to empower our teams to deliver. Now, if you kind of look at what we have within our company and here now, we have an innovative workforce with strong innovation ideas. We recognize the need to help our customers improve their operational efficiency. And we can do that through our robust and simple machine designs. ATS has a lot of knowledge internally that we can use. We have process knowledge, mechanical controls and software. There's tool makers, electricians that come in and can build. We have robotics, lots and extensive and varied robotic experience. We understand big data. We understand the power of Industry 4.0 and what you can do if you deploy Industry 4.0 functionality correctly. We now have the space and the processes to go and innovate. Concurrent to that, we have our customer relations. That is a cornerstone of what we're doing. And we have top to bottom company support. We have a common mission, and with these strengths and missions, we're here to win. Today specifically, I want to highlight 3 specific areas of focus over the past months. Some of these innovations we have integrating into systems today, and some will come out in the months to come. All of this is with the focus of improving customers' ability to drive operational excellence and sustained machine performance. The first area I'd like to talk about is our SuperTrak LMT platforms. ATS, we've been developing SuperTrak and LMT for many years. We are an industry first and a leader. The core technology already is fast, it's flexible, it's precise, and it's clean. But we want more from the system. How do we get more from it? We go ahead and we're making it more intelligent. We're hitting new markets, and we're creating new architectures and platforms to make it either larger, smaller, and change so that it can fit into more areas. The first area I'd like to talk about is the 90-degree rotate. Previously, we have a wide and a narrow 180 turn. It supports our carousel architectures, and it provides a great way to move pallets around, turnarounds, and back. All of our turnarounds are fully programmable. You can have stops and motion on the turnarounds, cam driven. Now we've released an asynchronous dial, 90-degree turns, and with the break after 90, you can make it a rectangle, a square, with various architectures and layouts is now possible. It's high speed and it's highly flexible, and it's available today. The other thing that we're changing is, historically, it's always been a carousel on a horizontal surface. We flip that on the side, and it's now an over-under configuration. Advantages is a decrease in floor space. and access of tooling to the pallet. You can put your product and your processing is frequently done on the top half of the over-under. Pallets can come back, they can be cleaned. Additional processes can happen on the lower side, and they can also move back quickly to the start. This allows the SuperTrak Gen 3 to go into spaces that were traditionally indexers, and now they can go into those spaces without expanding machine footprint and have all the flexibility and programmability of a Gen 3 track. The other area that SuperTrak is expanding is with the LMT software. Intelligence is always good. First off, we've got a very agile-based design department that does repeated releases on a schedule where we can prioritize all of our developments and all of our improvements, incorporate them into a release, and have a disciplined release schedule with a process. Agile has been very successful in taking large chunks of software, breaking it down into releasable areas, and delivering that to our customers. Within SuperTrak software, within the TrackMaster, it just takes a few hours to create a very detailed system simulation. This simulation is not just the images of the pallets moving on the screen. All programmability of velocities, accelerations, cam tables can be created in this simulation, and it eliminates and migrates much of the risk before metal is being cut and machines are being built. Optimizing. It optimizes output and it minimizes the footprint. Not only does it do all the motions, we can estimate both the power and the thermal consumption on these platforms. The biggest secondary advantage, not only do you validate your concepts and your architectures early in the concepting phase of the line, these simulations move directly into the product. So as you move on to machine build, you're not reconfiguring one configuration for simulation, a second configuration for the machine. It's a single configuration. It gets loaded in and you're running exactly as you had simulated in a very, very short time frame immediately after power on of the track. A very functional and optimized performance way to go forward. Not only does it work in the design and the move forward, once you're running your machine and you decide on changes or improvements, you're not required to go and put that onto a physical machine. Again, you can take the configuration, run it in the simulator, make your conceptual changes in the simulator, validate all of the same things that we do at the beginning. And when you go to make a physical change on your equipment, it's pre-tested, pre-proven, and it's a download and go. Very exciting for that. The final area of SuperTrak that's exciting for us is Pharma and aseptic. Here are some images with a commissaire isolator. Both of these, the SuperTrak Pharma with the isolator, are all leading technologies in the pharma world. For the SuperTrak grade A pharma materials, ISO 5 clean room rating, and all the advantages that are part of Track. Oil and grease free design. It's streamlined for airflow, not just the physical dimensions and the physical build of the system, having the smooth accelerations of the carriers, having no carrier-to-carrier contact. All of these things also focus on the streamlining of the system. It's flexible. It's no ongoing adjustments. There's very few moving parts with full control of the pallet motions, liquid sealed, and you can pull off a carrier at any point and the process continues to work. Not only are these possibilities, but optionally with vacuum or with pressurized systems, that can be incorporated into the design as well to maintain that correct enclosure and environmental control is compliant with these types of systems. All in all, what's coming out is the next level of flexibility and performance to move the LMT and the SuperTrak to continue to go and hit more markets and more use cases to expand where that product can run. Not only are we focused in the Innovation Center on the physical transfer of products, the digital transformation and what's happening in the world with Industry 4.0. We've been a leader in Industry 4.0 with our Illuminate Manufacturing Intelligence platform. It can perform part or some of the SCADA functions, or it can perform the entire SCADA/MES scope in a program and be the only interface between the ERP and the equipment. Very open and modular in that fashion, and very much designed by machine builders to go out and drive performance improvements on the equipment. For what's changing, our debug camera always has been very beneficial for ATS and our customers to go and isolate the correct video footage of what's going on in the equipment is now much more flexible. The most exciting bit is the high speed frame rates. So now we're up, I think, quite a bit higher than 750, but here it's 750 frames per second. You can go mount a camera and you can now see these very detailed high frame rate, high speed actions come through. We've got small footprint cameras. You want to have a camera on the end of the needle cameras. Go and mount this where you need to, put it into that hard to reach area that you can't even see, and then you can go and grab a live stream and targeted captures of specific actions happening on your equipment. Cameras, we're putting them into clean rooms, and we're getting more economical options. So some baseline cameras that can move and more flexible to hit more applications. The starting focus with the debug camera was very much, hey, how do we save and prevent maintenance people from sitting on the line and monitoring equipment? Why don't we just provide the video of what's going on? Again, coming back to this COVID world and what's happening, not only do you want to optimize people's availability, you really don't want a volume of people on your shop floor, and you don't want people sitting idle. So for COVID as well, here's an opportunity. You can put a camera there instead of a person. You can capture your machine details on video, and when you go in to do the work to go and impact your equipment, you've got detailed analysis of what's actually happening on your equipment. The other area of Industry 4.0 that we're investing in and driving in today is the AI manufacturing, and how is a revolution for development. Here's the opportunity and the practical way to make a machine smarter over time without investing in continuous programming limits and set criteria for isolating abnormal behaviors. We've got the infrastructure and the flexibility in place to go and deploy ML, whether it be on-prem or in the cloud, quite agnostic, and we can drive in your insights and drive in your ML processes to solve problems. Well, how do we do it specifically? It is ATS, we are focused on finding the production losses. So there's many ways to do it without analytics. Analytics just is that helping hand to get people over the finish line to say, you don't need to go and look at data. You don't need to go and look at reports. Here is a very user-friendly method to go and see your production losses. Part of the production losses is also to highlight the positive production trends. If you go and make a positive change and you don't acknowledge it or see it, how do you not always ingrain to keep that change and to move forward from a better spot? So both the production losses trends and the production positive trends, a high level of model deployment there to go and pick off both of these areas in a production system. A root cause. So not only are we focused in on production data and how the machine's producing, there's a high level of quality data available in the Illuminate system. Whether it be process quality from testers or vision, whether it be assembly data as you're putting the product together, all of that can be correlated into one spot, and suddenly ML can go and provide a learning ability to go and drive and do this root cause analysis of what's happening on the equipment. In the end, it allows you to proactively address the production losses. It allows you to proactively ensure that production gains are not easily lost, and you can deploy both predictive and preventative maintenance changes to the system. Closed loop, don't want to lose it. When we have the opportunity where a traditional control loop or where a limit-based loop doesn't work, do a model, have the model learn, have the model perform the closed loop control of the system as opposed to a controlled controls loop, and go drive improvements in your productivity through that. Why are we good at it? Why us and not others? It's the SMEs. So the data science, we are there with data science, but we also have the SME knowledge and the ability to drive corrective actions and optimizations. So concretely, what are we doing? We have real production. Our machines and our other machines that our customers use are creating real production. With those real productions is real problems and real data. From those, that's the three cores of starting an ML project to drive real solutions. So where does ML win? Micro and macro production trends. So the macro, the top line, how is my line doing? And what's my trend lines and what's significant on my macro production? All of that then, what feeds into it is the micro trends. What are the particular areas between false quality and rate? What are those multitude of minor things going on that have the biggest impact on the micro, and how do I continue on with my positive micro trends and address my negative micro trends that are holding me back? Lot changes, shift changes, batch productivity impacts. All of these are quite complicated. You can see the high line losses, but how do we win and how do we lose and how do we get the insights to go drive and improve these? The data is there and the machine can go and learn from what's gone on in the past and provide the insights to improve this. And finally, kind of alluded to in the earlier, the multivariable process analysis, where you have the combination of, and not limiting it to a machine. I should be careful here where I'm always talking about machines and process on the machines. There's SAP, ATS has a large SAP presence. That data has the potential, the data stored there has the potential to impact productivity as products come or leave the line. So between external data to the equipment processing on its productivity data, and the general process data being generated by the equipment. All of these variables, which you can do statistically, but the machine learning ability to do a root cause and to do associated impacts of these on the end good production is the way to drive in, the way ATS can drive in insights on very complicated processes with common models that can be deployed on multiple machines. That's the focus of number 2 pillar, where we started with the LMT, moving on to how we describe where we're going with Industry 4.0 and where we're going with both video and machine insights through machine learning and where we are on those journeys. The third area that I'd like to talk about is our Symphony technology. Symphony is an awesome platform. It's not just a method to move product. It's not just the controls and digitization of the shop floor. It's an entire process and modular to go out and drive digital manufacturing. Completely configured, not programmed, and completely modular and plug and play modules. For us at ATS, it's very exciting that we can deliver equipment sooner because of the level of standardization and commonality. As well, we can deliver equipment that meets rates that we are above and beyond what we've done with less tooling. It's lean. It's instead of driving, waiting for lots of events to happen and micro stops, it's very deterministic on its electronic camming and very able to have a very deterministic controlled outcome. So it doesn't rush the process time. With the flexibility of the platform and SuperTrak, we can go and expand process timing, but that non-process timing and that waste time where you're not doing a critical process is extremely lean and extremely efficient. Very high speed. So, and it's high speed on a small footprint. We're decreasing size compared to other, even more so compared to other architectures and layouts, and increasing the output on these smaller footprints. So the space is awesome. And the modularity. So we can fully debug and integrate a module that can plug into a system. If there's a change in the system and it needs to be reconfigured, these modules have come out, moved around, and been plugged back in and allowed for a huge amount of flexibility. And it's not just in the mechanical, the modularity exists in the control system as well, such that the controls are modular and they move with the module. So you're not doing a mechanical swap and reprogramming a program. It's a move that's a move, and very flexible and exciting. So here is a video that would show the Symphony system. Thank you very much. Exciting to see the Symphony machine in action, and exciting to go over the three pillars that we discussed today. From LMT through to Industry 4.0 and Illuminate and right into the Symphony products. Those are three areas of what's new in LS. That's combined both what's out there and available and what's coming down the pipe. Look forward to doing more changes, more innovations, and more new things, and looking forward to solving more problems. That's the great thing about automation today and where the industry is going, and that we have the opportunity to solve a lot of problems. Appreciate your time and look forward to seeing you at one of our innovation centers around the world.